Okay, so next let's look at similar triangles. So similar triangles are basically triangles that, again, similar. But these have a little bit more criteria to classify them as similar. So we either have AAA, SSS, or SAS. So if you can prove one of these criteria, then you can say that the two triangles are similar. So either the corresponding angles have to be equal. So what that means is all the angles in the triangle for two shapes need to be the same, the exact same, in order for the two shapes to be similar. Okay, so that's one of the criteria. If you can't see that, or there's not enough information to deduce that, you can use the second criteria, SSS. All the corresponding sides need to be in the same ratio. Now, triangles have three sides, so all the three sides have to be in the same ratio. But if you can't see three sides, then you can't use this criteria. And then the third criteria is when you can't see all the three angles, or you can't see all the three sides, is SAS. And SAS is basically having two sides that are the same ratio and the included angle being equal. So what is the included angle? The included angle is the angle that is sort of between those two sides. So for example, if we look at these two shapes, we can't deduce that they're similar based on AAA. And that's because we don't have three angles or even two angles. We can't deduce that these two triangles are similar because using SSS because we haven't been given three sides. Okay? So therefore we have to use SAS in this case. And the way that SAS basically works is we look at the corresponding sides. Okay? So this side and this side and this side and this side, and we need to see if they're in the same ratio. So now it might not be obvious, but try and sort of orientate the triangles in a similar direction. The way I like to do it is, well, I look at the included angle. So this is the included angle. As you can see, it's sort of in between the two sides. And one part of the SAS is sort of proven. And the reason for that is because these two angles are the same. So what I'm going to do is I'm just going to orientate this triangle in a different way so that I can see the two sides and work out the ratios. So E, F, D. So I've just sort of like flipped it or reflected it. So I have 84 degrees here, and I have 10 here, and I have 16 here. So now what I'm going to try and do is I'm going to see if the same sides are in the same ratio. So 8 to 16, and we also have 5 to 10. So 8 to 16, if you divide both of them by 2, it can be 1 to 2. And similarly, if you divide by 5, sorry, this one not divide by 2, if you divide by 8, it'll be 1 to 2. And this one, if you divide by 5, it'll be 1 to 2 as well. Yep, so they're in the same ratio. So that means this is a similar triangle. So that is the sort of thinking that is required in order to prove if two triangles are similar or not. AAA, SSS, or SAS. One of them is enough. Okay, so next, corresponding angles have to be equal. Okay, so what does this mean? So basically what this means, angles. So we have a lot of different types of angles. We have complementary angles, supplementary angles, so corresponding angles, co-interior angles, vertically opposite angles, and alternate angles. Now you do need to know all of these angles and how they sort of work, and also how to identify them. And the reason for that is because they might give you a diagram with one or more of the angles are missing, and you have to use the angles that are given to you in order to determine the rest of them. So you need to be using these rules, so not just know them, but you should be able to use these rules and apply them to questions where it's not really obvious which angle is present. So let's look at all of these. So first of all, what is a complementary angle? So complementary angle is basically angles that when you add them up together, they add up to 90 degrees. So for example, J and K are complementary angles. Okay? What about supplementary angles? So supplementary angles are angles when you add them up together, they add up to 180 degrees. Then what about corresponding angles? Okay, so corresponding angles are basically angles that are equivalent. And the way that I like to think about them is if you have two parallel lines, if you have two parallel lines and there is a line going between them, this angle and this angle are corresponding, because if you think about it, they sort of make the same angle with that line. So these are both parallel lines. It's sort of like making the same angle. So these angles are called corresponding angles because they are the same. Next, we have co-interior angles. So when I think of co-interior angles, I think of the C. So C for co-interior. And the reason why I think of a C is because, sorry, let me just rub this out. Okay. So when you have, again, parallel lines, if you can draw a C like this, okay, the angles that form this C has to be parallel lines though. So don't forget that, has to be parallel lines. But when you can form a C, the angles that are in the C always add up to 180 degrees. Okay, so they're co-interior angles. They always add up to 180. So if you know D, you can work out what F is. And similarly, this C over here, okay, so you can not only form a C in that direction, you can also form a C here. So E and C will also add up to 180 degrees. So these are co-interior angles. Next, we have vertically opposite angles. So vertically opposite angles are basically angles in which you have two lines crossing each other. Okay, so whenever you have two lines crossing each other, the angles that are directly opposite each other in that cross. So whenever you see like a cross, the angles that are opposite to each other inside that cross are the same. They're always the same. So B is equal to C. A is equal to D. E is equal to H. Anytime you see a cross, the angles that are opposite to each other in that cross are the same. Next, let's look at alternate angles. So these ones, when I think of Z. And the reason why I think of Z is because if we can draw a Z when you have parallel lines, okay, so parallel lines, when you can draw a Z like this, the angles that are over here inside that Z, they are the same. Okay? So C and F are going to be the same. So whenever you see a Z, you should always think of this. So another example would be this Z over here. So just draw it in a different color. So we have this Z over here as well. So E and D will also be the same, but only when you have parallel lines. Okay, so those are all the different types of angles. Again, let me know if you have any questions. Okay, so next let's look at the different types of triangles. So just a few properties of triangles is that the sum of their interior angles is always equal to 180 degrees. So basically what that means is the internal angle, so not any external angles. If you form like a line like this is an external angle. We're talking about internal angles like this. So all of the internal angles in any triangle have to equal to 180 degrees. Otherwise, it's not a triangle. The next property is specific to equilateral triangles. So equilateral triangles are triangles in which all the sides are the same. So what that means is they have the same length and the angles included between two particular lines have the same angle as well. And that angle is 60 degrees. So all the angles in an equilateral triangle are 60 degrees and all the sides are the same length. Now the sides don't have to be a specific length. So it could be, 60, 60, 60, but it have to be the same for each one. Isosceles triangle is basically a triangle in which two of the sides are the same and two of the angles are the same. So when you look at the two sides, the included angle is the one that's different, but the other angles are the same. So these angles are the same and these sides are the same length as well. Next we have scalene triangle. So this triangle is basically when nothing is the same. So no same lengths, no same angles. And then finally we have right angle triangle. So right angle triangle is basically where we form a 90-degree angle. So any triangle that has a 90-degree angle is a right angle triangle. And these triangles are really important for the next few topics that we'll look at.